Let's demystify the Fourier series in this video. It's a very important topic in partial differential equations. And you see the animation. After this animation and this video, you'll be able to understand fully what is Fourier series and how it is going to be useful in engineering examinations. Here you see initially the equation whatever initially is given to us, that is in the black color graph, and the Fourier series is in the red color, and this red color Fourier series is converging with the black color function x, so that you will get a converged value of the Fourier series and you will get a series which is going to be useful for various engineering applications like heat evolution, finding using the heat equation, and also applying for heat applications in engineering, and also in the diffusion mechanism, and in many engineering applications. This particular Fourier series is very important and it should be understood fully. Now we will go into the physical problem. Now here I have taken a very good example of Fourier series in a piecewise functions, and basically I am from Maths and Science by IITian channel, and I am an IITian, and there is one website also, maths&science.com, in which I will be explaining in detail about I will be writing the notes and also blogs, and it is just now started, that maths&science.com, whereas Maths and Science by IITian channel is there for the last 1 year, and I have already released more than 350 mathematics videos. Please pay attention to this particular problem. It will demystify what is required to be found out in the Fourier series and how it will be useful for the engineering applications and how it is to be solved. Let's move further. What is the actual function given here? Actual function is function x is, it is a piecewise function. It is equal to 1 when absolute value of x is less than pi by 4. It is equal to cot x when pi by 4 is less than absolute value of x is less than pi by 2, and it is equal to 0 otherwise. For all other values of x, it is 0. Now, whenever you get a problem like this, it is better to draw the function x, original function x, and understand from it what is required. Let us draw. First step is, in the solution, draw function x. How to draw the function x? Function x is equal to 1 when absolute value of x is less than pi by 4. That means it has a jump at minus pi by 4 and plus pi by 4, because absolute value of x is less than pi by 4. It is not exactly at pi by 4, at minus pi by 4 there is a jump. That value is 1. That means, let us draw first one. Let us say it is function x and it is x. function x is equal to 1. Let me say this is 1. Function x is equal to 1 when absolute value of x is less than pi by 4. That means at minus pi by 4, it is minus 1 here because absolute values we are using. It is plus 1 here. There is a jump like this. Please try to understand this jump. There is a jump like this. That is first point. Here it is, this value is minus 1, here its value is plus 1. Please try to understand. Now, from minus pi by 4 to plus pi by 4, what's happening? From minus pi by 4 to plus pi by 4. Here it is plus pi by 4. What is happening to function? The value 1 is getting extended. That means this is the value from minus pi by 4 to plus pi by 4. Jump is here. Jump is here. And after plus pi by 4, it is cot x up to pi by 2. Less than pi by 2 means approximately. It is cot x. Sir, it should be little curved. Now, after pi by 2, otherwise it is 0. And on left hand side, if you see, less than pi by 2, it is 0. That means, let me shape this like this. And here it will be minus pi by 2. That means there is a jump between at minus pi by 4. For clarity, for brevity, I will draw the diagram like this again. Please try to understand. It is very, very important to understand the function first. If you understand the function, what happens? What you have to do in mathematics, you will understand. This is x. This is function x. This is minus x. This is minus function x. Critical points. I will write it as minus 1 here and plus 1 here. Minus pi by 4, minus pi by 2, plus pi by 4, plus pi by 2. Because these are the values. The function is oscillating pi by 4, pi by 2. In other places it is 0. That means in other places it is 0. After pi by 2 it is 0. Here also after minus pi by 2 it is 0. The function. So that these are confirmed. Now at minus pi by 4 It jumps from -1 here, and here it is +1 at minus pi by 4. There is a jump. And from minus pi by 4 to minus pi by 2, it goes this way. And here also plus pi by 4, it will be horizontal. And plus pi by 4 to plus pi by 2, there is a curve like this, because it is cot x. This is cot x. This is cot x. And it is here, this is when function x is equal to 1 plus 1. This one. Please try to understand this. Now, this is the piecewise function which is defined, given to us. Now, what we have to do is to find a Fourier series in such a manner that Fourier series, when the number of iterations are done, in the Fourier series, when number of iterations are done, please try to understand the meaning of this sentence. It aligns with the given function. You just see. When at the 50 iterations, when n is equal to 50, it moves this way. This way, and it moves this way. It moves this way. Initially, the graph of the Fourier series is the initial graph is like this. Please try to understand this. Once you understand the concept, then while doing the problem, you will be easily able to solve the problems in the examination very easily. Try to understand. I am spending some time in the concept. It is like this. Fourier series, initially it is shown as don't take it. It is not drawn on scale. Just to make you understand, this I have drawn like this. And the actual curve is our function x curve is like this. Now, this is the Fourier series curve. You can see the video and make it very easy. Animation you can see, and this is the actual. function x. And when number of iterations if we go on giving to it, this Fourier series curve aligns with the given function x with some little differences. That is, Fourier series is an approximation. Please try to understand. Fourier series is an approximation to actual function. Now, mathematically we will try to solve it. What is happening physically now you understood. Now we will apply our knowledge in mathematics and let us try to solve it. Mathematically, how we can solve this particular problem. You try to understand the basics. If some function x is given, function x is equal to given. It is given with some conditions. Then we have to approximate this function x to Fourier series. We have to find a series where function x and Fourier series get aligned with each other, so that the discontinuities can be addressed in the real engineering conditions. How they can be? Here 2 pi periodic function is given. If you see the equation, x is minus pi by 4 to rather minus pi by 2 to plus pi by 2 and further. Hence, if we take it from minus pi to plus pi, it is a periodic piecewise function between the intervals minus pi to plus pi. That we can say it is a 2 pi periodic function. If there is a 2 pi periodic function, then the general solution for a Fourier series is given by the general solution for a Fourier series. What is the general solution for a Fourier series? Function x is equal to, please remember this, a naught by 2 plus sigma. Whenever there is a series, there will be sum. From n is equal to 1 to infinity, an cos nx plus bn sin nx. N is the number of iterations we are applying. If n is equal to 1, there may be lesser alignment. N is equal to 2, there may be more alignment. N is equal to 3, there will be more and more alignment. N is equal to 50, there is a further better alignment. If n is equal to 100, there may be further better alignment. This is the equation of any Fourier series. When we convert a function into a Fourier series of 2 pi period, this is the solution. Now, the main question is, function x we know. What is a naught? What is an? What is Bn? N we know, n is equal to 1 to infinity. N is equal to 1 to infinity. A very good concept of Fourier series and very good invention of Fourier series, useful in engineering applications. Now, what is A0 given here? A0 is equal to 1 by pi into integral minus pi 2 plus pi function x dx. Please remember this. The value of A0 can be found out from this. You know function x. Whatever may be the value of function x, A0 is this. Then what is An? Please pay attention to these. An is equal to 1 by pi integral minus pi to pi function x cos nx. It is a 2 pi periodic function we are taking. Bn is equal to 1 by pi integral minus pi by pi 2 plus pi function x sin nx dx. Because the interval is from minus pi to plus pi we have taken, and the equation also denotes that, the function x also denotes that. Now, in between minus pi to plus pi, what is that behavior? We have seen graphically. Now let us try to understand mathematically. What is that behavior? At minus pi by 4, it's not defined because discontinuity jump is there. Now, let us take one by one. What is written in A0? A0 is equal to 1 by pi into, let us calculate A0, An and Bn, and we will put it in the formula. Then we will go for the total function x. What is function x? Function x is equal to A0 by 2 plus summation from n to infinity, n is equal to 1 to infinity, An cos nx plus Bn sin nx. Now we are finding A0 for this particular problem. A0 is equal to 1 by pi into integral minus pi to plus pi function x dx. Here, what is that is given between minus pi to plus pi? First is that between plus pi by 4 and minus pi by 4, function x is equal to 1. You see, absolute value of x is less than pi by 4. This. That means x varies between minus pi by 4 and plus pi by 4. Function is defined in 3 stages. Let's go from one stage to another stage. In the first stage, absolute value of x is less than pi by 4. That means function x is equal to 1. Integral minus pi by 4, please pay attention. If you solve this problem perfectly, I think whatever problems that come in the examination, you will be able to understand. Please understand the concepts. I am little bit slow to make you understand the concepts. Function x is equal to 1. It is function x dx, no? Function x is equal to 1 dx. Next, what is the limits that are given for x value? Pi by 4 to pi by 2. Absolute value. Absolute value of x is less than pi by 4. That means it can be up to minus pi by 2. Up to minus pi by 4. And other thing plus pi by 4 to pi by 2. It is split. That intervals are split here. Here what I will write? Integral minus pi by 2 to minus pi by 4. What is that? Cot x. Function x is cot x dx plus, because I want from minus pi to plus pi, still it is there, from another integral pi by 4 to pi by 2 cot x dx. For all other values, the function x is 0. Because you just see, minus pi by 4 to plus pi by 4, already something is defined. Now, minus pi by 2 to minus pi by 4 cot x is defined. Plus pi by 4 is already completed, minus pi by 4 to plus pi by 4. Now we require plus pi by 4 to plus pi by 2. And for all other values, function x is equal to 0. Please try to understand how I got my a naught. Now you just see. Here if you see, cot x, it is an even function or an odd function? It's an odd function. And there are symmetric values for an odd function. You need not directly calculate the integrals. Please try to understand. Minus pi by 2 to minus pi by 4 or plus pi by 4 to plus pi by 2. Because it is an odd function, minus and plus, they get cancelled and they become 0. You just see, your intuition, you have to apply your basics in the mathematics, in integration. You need not find the integral by hard work, it becomes 0. Then a naught will be equal to 1 by pi into 1 into dx is x minus pi by 4 to plus pi by 4. Now what will be its value? You tell me. 1 by pi into pi by 4 minus pi by 4. That is equal to 1 by pi into pi by 2, that is equal to 1 by 2. A naught is equal to 1 by 2. Then in the equation function x is equal to a naught by 2. Hence we have to find out the first, we have found out the first value, a naught by 2 is equal to 1 by 4. You got it? Now, my next step is to find out an. What is an? An is nothing but an is equal to, from the definition it is given, 1 by pi into integral minus pi to plus pi function x cos nx dx. First, let us try to understand the function x into cos nx. What it is? What is function x? It is only the important part is function x is equal to cot x. There only the problem comes. Otherwise, wherever function x is equal to 1 and 0, when it is 0, the integral will be 0, and when it is 1, there is no problem. Because what happens? Here you see, first band is minus pi by 4 to plus pi by 4. In the first band or first interval, function x will put an is equal to 1 by pi into integral minus pi by 4. Let us not change this because it is given in the behavior of the function itself. Function x is 1 into dx. No, not dx, it is 1 into function x is 1 cos nx. Do you agree? Dx. Because we are calculating an, not a naught. Then next comes next interval is minus pi by 2 to minus pi by 4. These intervals only very important. For that only I have shown you the Fourier series animation. This will be cot x into cos nx dx. Next part will be integral plus pi by 4 to pi by 2. Cot x into, what is the value? Cos nx. You just see, here also the principle of odd function. Cot x is an odd function, cos x is an even function. Here you see, cot x is equal to odd function, cos x is equal to even function, and odd function and even function are multiplied. Then automatically, for the same type of negative limits and positive limits, they get cancelled. Minus into plus is equal to minus. That means they behave like odd function, and hence integral minus pi by 4 to minus pi by 2 minus pi by 2 to minus pi by 4, sorry. Some odd function into dx plus pi by 4 to pi by 2 some odd function to dx is equal to 0. Please remember this, which we have applied in A0. Here in AN also it is applied. Hence, ultimately what is left over in AN? This is what is left over. Hence, AN is equal to integral 1 by pi into minus pi to minus pi by 4 to plus pi by 4 cos nx dx. It is cos 2 theta, cos 5 theta, cos n theta, d theta. That's a simple, very easy integral. That is equal to 1 by pi into cos theta is sin theta, sin nx by n minus pi by 4 to plus pi by 4. That implies what it is? An is equal to 1 by n pi into sin n pi by 4 minus sin n pi by 4. Sin n pi by 4 minus sin n pi by 4. That implies an is equal to 1 by n pi into 2 sin n pi by 4. That is equal to 2 by n pi into sin n pi by 4. That implies an. What is the value of an? An is equal to 2 by n pi into sin n pi by 4. The main problem comes with Bn. A0 we have found out, An we have found out, now we have to find out Bn. It is the biggest part and it is the most important part where we have to use our logic. What is Bn? Bn is equal to 1 by pi. What is Bn? Bn is given as minus pi to plus pi function x sin nx dx. Minus pi to plus pi function x into sin nx dx. This is Bn. Yet function x is equal to 1. Minus pi by 4 to plus pi by 4. Because we have split this minus pi to plus pi into three different intervals. First is minus pi by 4 to plus pi by 4, where function x is equal to 1 and function x is equal to 0 otherwise. Because of the symmetry, sin nx is an even function. Odd function. What is sin nx? odd function. When it is an odd function, and function x is equal to even when it is equal to 1 and 0. Hence, these two values, when function x is equal to 1 and function x is equal to 0, they are not going to contribute anything for Bn. This is what is the logic you have to apply. Then ultimately what Bn is going to be? Bn is going to be contributed by cot x, contribution from function x sin nx only where function x is equal to cot x. In that interval only Bn will have a contribution. What will be the Bn contribution? Pi by 4. Function x is equal to cot x when pi by 4 is less than absolute value of x is less than pi by 2. Between pi by 4 and pi by 2, from minus pi by 4 to plus pi by 2, minus pi by 4 to plus pi by 2 can be minus pi by 4 to minus pi by 2 and plus pi by 4 to plus pi by 2. This is one, this is another one. That means because of the behavior of that cot x into sin nx, the integral will be added 1 to 1. If this is I, this integral, this is I, then our total value of Bn will be 2 by pi. Instead of 1 by pi, it will become 2 by pi because both are added. And interval can be written as pi by 4 to pi by 2 by removing the negative sign. From negative sign also one I, and from positive sign also another I. Then it will be cot x into sin nx dx. Let me say this as I. Then this will be equal to In, let me say, because n is there. 2 by pi into In. Then the main challenge in this problem is to find out In. In is equal to integral pi by 4 to pi by 2 cot x into sin nx dx. That implies That means for different values of n, I1 will be pi by 4 to pi by 2 integral cot x sin x dx. If n is an odd, then there will be something different answer. If n is equal to even, the answer will be something different. That means there will be a different behavior for different values of n. What is the value of Bn? Bn is equal to 2 by pi into integral pi by 4 to pi by 2 cot x sin nx dx. Cot x into sin nx, what will be value? Just think over. Cot x into sin nx, not x, is equal to cos x by sin x into sin nx. Do you agree? This trigonometrical identity, the value of this trigonometrical identity, we can use cot x into sin nx For example, if n is equal to 1, it implies cot x into sin nx is equal to cos x by sin x into sin x, that is equal to cos x only. If n is equal to 2, cot x into sin 2x, it is not sin x, 2 sin x into cos x, that is cos x by sin x into 2 sin x into cos x, 2 cos square x by sin, 2 cos square x. Are you able to follow? When n is equal to 3, cot x into sin 3x, this will be equal to 1 plus 2 cos 2x, and it goes on. That means we are getting some equation like some value for Bn. Bn is equal to what is that? 2 by pi into integral pi by 4 to pi by 2 cot x into sin nx. But for different values of 1, n, the value of cot x into sin nx is changing. And we have to find out the different values of Pn. It is a lengthy process, but it is better if you go on finding the B1, B2, B3 values. What is B1? B1 is equal to 2 by pi into integral pi by 4 to pi by 2 cot x into sin x, because sin nx is sin x, that is equal to 2 by pi into integral pi by 4 to pi by 2, it will be cos x dx. What will be its value? B1 is equal to, what is the value of B1? 2 by pi into, what is the integral of cos x? Integral of cos x is nothing but sin x. Pi by 4 to pi by 2, that will be 2 by pi into, sin x will be sin pi by 2 minus sin pi by 4. Sin pi by 4. That implies B1 is equal to 2 by pi into, sin pi by 2 is 1, 1 minus sin pi by 4 is 1 by root 2. 1 by root 2. That is equal to 2 by pi into 1 by root 2 into root 2 minus 1. That implies B1 is equal to root 2. When they get cancelled, 1 by pi will be there. Root 2 into root 2 is 2. 2 minus root 2. 1 by pi into 2 minus root 2. This is B1 value. In the examination, you may be asked to find out B1, B2 or B3, or you maybe simpler equation may be given. I have taken the very tough question here. It is made by me personally, so that you will understand the concept clearly. Now, try to find out B2 now. B2 will be 2 by pi into integral pi by 4 to pi by 2 cot x into sin 2x. Cot x into sin 2x dx, which we have already done. Cot x into sin 2x is equal to 2 cos square x. 2 by pi into integral pi by 4 into pi by 2 2 cos square x dx. 2 cos square x is nothing but cos 2x is cos square x minus sin square x. One plus cos 2x. That is equal to 2 by pi into B2 is equal to integral pi by 4 to pi by 2. 2 cos square x is nothing but 1 plus cos 2x dx. That is equal to 2 by pi into 1 plus cos dx dx. If you do integration, it will be x. Now it will be x plus cos 2x is minus sin 2x by 2. Integral of cos x is sin. Sorry, it is plus. This whole will be pi by 4 to pi by 2. B2 is equal to, by doing all this, we will get the answer 1 by 2 minus 1 by pi. That you please cross check. And B3 will be 10 minus 7 into root 2 by 3 pi. These are all preliminary integration. And B4 will be 1 by 2 minus 2 by pi. This goes on. Hence, ultimately what we get the answer is function x is equal to a naught by 2 is 1 by 4 plus an what is the value of other term? An 2 by n pi sin n pi by 4 sigma n is equal to 1 to infinity sigma n is equal to 1 to infinity 2 by n pi into sin n pi by 4 plus into cos nx because an cos nx plus sigma n is equal to 1 to infinity bn sin nx. For different values of n, we will get the different values of bn. Bn is defined that way. This is how we will get the series. And this Fourier series, even though it is tough to get, this Fourier series gets aligned with our function x, and this is the Fourier series how we have to write. And in GATE 2026, 1 or 2 questions are given on Fourier series, which are very easy. You can do it in less than half a minute. That I will be solving in the next class. I will be taking 1 or 2 examples from GATE examination, real examples, and I will be solving so that you will appreciate this particular solution. And with this, I wanted to stop this lecture. Best of luck to everybody. Thank you for seeing my lecture. Thank you for viewing my lecture, and thank you for listening to me. If you feel there is a value addition because of this lecture to you, kindly hype this lecture. Kindly share this lecture to known people. Kindly subscribe to my channel and give my channel details to the known people. My channel is Maths and Science by IITian, and kindly visit my website maths&science.com for further notes. Thank you. Best of luck. Next lecture, I will be coming up with some few examples from GATE examination. We will solve them together. Thank you.